Welcome. In this video, we will simulate and design a braced excavation adjacent to a TBM tunnel with DeepEX software. Initially, we will access the Soil Types dialog, where we can edit the soil properties for each soil. The program allows you to define properties directly or estimate them from test data. In the Elastoplastic tab, we will change the soil's behavior to exponential. In the Borings dialog, we can define the top elevation and select the soil type for each layer. We will use a fill layer, followed by a medium dense sand and a glacial till. Open the Tunnel wizard. We will select to create a TBM tunnel. We can define the number of construction stages, and we can adjust parameters such as the lining sections and the position of the tunnel by editing the tunnel center coordinates. Next, we will select to automatically create the segmental linings and calculate the joint stresses. We can create the default TBM machines or add our own properties, and we can assign the machine to the tunnel. DeepEX will generate the tunnel on the model area. We add a new construction stage, and we select to activate the wall. We access it, and we can define the wall depth. We select to edit the wall section. In the dialog that appears, we can edit the wall section type. In this example, we will use a concrete diaphragm. We can define the wall thickness. In the Concrete Rebars tab, we can adjust the longitudinal and shear reinforcement for our diaphragm wall. We select to add a right wall on the model area, accept to edit it, and we will change the leftmost coordinate to 12 meters. We add a new construction stage and we excavate between the two walls to elevation -3 meters. We add a new construction stage and we draw a strut connecting the two walls. In the dialog that appears, we change the strut elevation to -2.5 meters and we edit the strut spacing. We add a last stage and we will excavate and dewater to elevation -6 meters. We will draw an external surface load on the model area. We can adjust the load coordinates and the magnitude. In this example, we will use the finite element analysis method. We access and change the FEM mesh density to medium. For each wall, we will define as wall friction 66% of the soil friction angle. Analyze the model with the finite element method. The summary table includes critical results for walls and supports. On the model area, we can see result graphs such as moments, shears, displacements, and settlements, both for the excavation walls and for the tunnel linings for each construction stage. We can review the generated finite element mesh and display result shadings such as soil mass stresses, displacements, and settlements. Additionally, we can show on the model area tunnel results such as the segmental lining joint stresses and rotations for each construction stage, volume losses, and more. Thank you for watching this video. Visit our websites and find out how to overcome your geostructural challenges with our programs.